This is another ASE practice test. This is General ASE Practice Test 2. So I figured I'd go ahead and give you guys the same sort of format as I did last time. We'll do the questions first, and the second set of slides down at the bottom will be the answers. And I've got a couple of little video animations for you on some stuff. So, question 1. Testing a 12-volt circuit. The meter reads 12.6 volts at the battery and 1.5 volts across a closed switch with the load operating. Does that mean the switch is functioning perfectly, or that there is excessive resistance in the switch, or the switch failed open with no current flow, or the battery is slightly discharged? Question 2. What happens in a series circuit if the total resistance is doubled? A. The current will be doubled. B. The circuit will blow a fuse. C. Voltage will increase 2 times. Or D. Current will drop by 1/2. Question 3. AC is not cooling on both sides. The pressure is high. Does that mean the system's undercharged, the expansion valve is restricted, the fan or poor condenser flow will be an issue, or the evaporator core is frozen over? Question 4. AC compressor clutch is not engaging, but there is 12 volts at the clutch. Do you replace the control head, check the clutch coil and ground, measure AC clutch diode bias, or check high side cutout switch? Question 5. What is a common cause for a PO171? Would it be a leaking injector, high fuel pressure, ECT reads too high, or post-mass airflow air leak? Lambda is consistently above 1.0. Does that mean the ignition timing is retarded? PCM is injecting more fuel? PCM is injecting less fuel? Or would we have a skewed downstream oxygen sensor? Question 7. While performing a cylinder leakage test, air is heard escaping from the oil filler cap. Does that mean the intake valve is not seating, the exhaust valve has a crack, worn piston rings or cylinder, or the head gasket must have failed? If your clearance is that tight, then that doesn't mean let's see, we got a problem there. What I'm saying is you don't have enough clearance here. The narrower this band is, the more clearance you have. Well, this one here has got more. I mean, in other words, it's tighter than even than that. So you've got 8/10 thousandths of an inch there. And so what does that mean? Does that mean the main bearing cap should be refiled, the engine must have been rebuilt, the test is being done incorrectly, or the crankshaft thrust bearing is worn? Question 9. The ATF is dark brown, and a brand new shop customer asks for a transmission fluid change and nothing else. Test drive the vehicle first, drain the converter, coolant contamination in fluid, or the transmission needs to be rebuilt. Alright, question 10. A harsh shifting transmission has high line pressure. The transmission fluid level is low. Does it mean there's a faulty EPC solenoid or circuit, or a failing torque converter clutch, or a clogged transmission fluid filter? The answers come next. We talk a little bit more about these than we did about whipping through the questions. Testing a 12-volt circuit, the meter reads 12.6. Okay, you might notice that current's got to be flowing, right? Current has to be flowing in order for you to get a reading at all like this. So like if your load's completely open, you're not going to get anything. But if you're showing 1.5 volts drop right here, you got a little bit too much resistance at the switch. Now you're going to have resistance at every connection. It doesn't matter if it's even a solder joint. You're going to lose some. I've actually seen wires that didn't have any breaks in them and weren't soldered or anything drop voltage, so that's another story. Look at this. I made you a little video here. No resistance. Notice the voltages up here. Pay attention to that. You got resistance. I added 1.1 ohms. No resistance. These are millivolts, see? And you got more voltage available at the load, see? See how that works? Alright, with no resistance, you got very little drop, and you got practically full, well, a whole lot. See, 12.6 versus 12.39 is very little drop. If you added this to that, you'd get this, how that works. What happens in a series circuit? If the total resistance is double, current will drop by 1/2. The voltage will be shared by two loads. If these are two fans, they're going to run at half speed. They're going to divide the voltage between them. The switch closed. Alright, single load series circuit. Now watch this. I got another little video here. Alright. See how the amps are changing down here? Alright, see that's with one, you got 1.5 amps. The small motor. And with this one here you got 7.8. Let's see there. That's not too hard to understand, really, the way I put it together. AC not cooling on both sides would be a fan problem or poor condenser airflow. Now both of the evaporator and condenser are heat exchangers. If you're the crazy thing about this stuff here is it can go right through the AC condenser and stop at the radiator. When you look at the front of the AC condenser, you may not see any of this. This is trapped between the condenser and the radiator, and it's hidden unless you pull this cover off that's that's over this thing usually, or even take the radiator loose and tilt it back. You won't even know this is here, and that can cause overheating, but it can also cause high head pressure on and a lack of cooling. If the fan is not working, you'll have the same kind of issue, but only when you're sitting still. You won't typically have a problem driving down the road if you just got a fan issue. Alright, on this one here, the voltmeter is not measuring voltage across the clutch, but it's connected to a different ground. So we're getting voltage here, 12.6, but the clutch is not energized, so that's going to have to be the clutch coil is open or the ground isn't continuous and the clutch can't work. This was one that we saw on a Buick. Somebody had misrouted the wires, and this belt sawed that ground wire. Of course, it could have sawed any of the wires, but it sawed the ground wire in two. And the only symptom this car had was that the air conditioner had stopped working. The crazy thing about this Buick, it was a 93 model. Somebody had pulled all the R12 out and pumped it full of R134 and did a perfect job of it, but they didn't change the charge fittings, which was wacky as all get out. So anyway, we had to replace the charge fittings. We pulled the refrigerant out and all that nonsense with it, put it in the machine. And because I had a machine that would do R12 or R134 at the time. Anyway, this one right here had a cut ground wire. We fixed the ground wire and we tied this harness back so that it couldn't get against the belt again. And that was one that we saw in the shop. Now we're going to have a post-mass airflow leak. Of course, you could have low fuel pressure. You could have a skewed map baro sensor. If it thinks you're at high altitude, it's going to not put enough fuel in there. Oxygen sensors will pick it up. Fuel trims will respond. And it'll give you a PO171. If you've got a skewed mass airflow reading, and it doesn't have to be skewed very much, it can toss you this code and make the fuel trims go way off. Missing oil filler cap gasket. Let's unmetered air in that way, or if the oil filler cap is off or loose. You can demonstrate this by hooking your scan tool up, watching the fuel trims with the engine running. Take the oil filler cap off and watch what the fuel trims do. If you got a wrong PCV valve, I've seen that somebody put the wrong PCV valve on there that had too much flow, and it caused the fuel trims to be all screwed up. That's something you would never think about. Lambda reading is constantly above 1.0. Now, that's going to be putting more fuel in there, and you can get a closer look at these scan tool readings right here. With wideband O2 sensors, lambda is a direct measurement of the air-fuel mixture, and it makes it a faster way to spot a problem than waiting for fuel trims to react. Although, if you think you've got one fixed, like if you had fuel trims that were way off, like this one right here, your long fuel trim, your short fuel trim on this one here would be at 0 if the long fuel trim could tilt the mix it out of enough. It's going to try to, the long fuel trim is going to tilt off to one side to try to get the short fuel trim to stay at 0. And that's basically covering up for a problem. But whenever you look at this, you're going to see, let's say you clear this, right? And you got it, this long fuel trim back at 0, and you're watching your long and your short fuel trim. And if you think you have it fixed, and let me say you found a leak or some, you did make some repair, start it up and watch that short fuel trim. If it goes crazy and starts to go plus again, you've got, you're not done. You got to work on something else and figure out what else is wrong with it. Anyway, so you compare fuel trim to lambda, and so fuel trim's what the computer's doing, lambda's what the sensor sees basically. While performing a cylinder leakage test, air is heard escaping from the oil filler cap. That means worn piston rings or cylinder. Now, I deliberately created this illustration with these ring gaps stacked. You see that? That's not supposed to be like that. The ring gaps are supposed to be on opposite sides of the piston, these compression rings. And that, if you've got stacked rings, you'll have cylinder leakage past those ring gaps. It'll go right past all of them. And first time I ever saw that, I was a young teenager, and my dad was pulling an engine apart, and he pointed out to me that the ring gaps were stacked. You might not even think about that, but when you're putting rings on a piston, these gaps need to be on the opposite side of the piston, not stacked on top of one another. But there can be other reasons why it's going, past the rings, if they're worn out, or if the cylinder walls are damaged, or if you got something wrong with the piston and that kind of thing, so on and so forth. Anyway, this is a little thing, a little guide here. Less than 5% leakage, 5 to 10% leakage, 10 to 20% leakage. Greater than 20% means you got a problem. So you can look at those little. And again, if your clearance is that tight, then you basically have the weight of the crankshaft resting on the bearing and squishing the plastic gauge out too much. So you make sure that you do something to get the weight off of that crankshaft. Like I say, a business card on the adjacent bearing or something like that. And that's pretty much the answer to that. Let me know if you think that's a good idea. I used to do that whenever I was doing line mechanic work. Gauge. If this thing is dark brown and a brand new shop customer asks for a transmission fluid to change and nothing else, that can be a trap. I'm not saying that you should see the worst in every customer, but when I was at the Ford dealer, we used to have issues where a customer would have a transmission problem, and in their own mind they'd say, well, I'm going to go and have the transmission serviced and see if that takes care of it. And if it doesn't take care of it, a devious customer will come back and say, hey, after you serviced my transmission, it developed a problem. Well, if you've been a long way driving a transmission and there's varnish all over the valves, and then you put new fluid in there, sometimes it'll break that varnish loose, and it will cause the valves and the valve body to stick, and you'll develop problems because you went too long without servicing it, and then you serviced it, and it washed varnish that was really happy where it was off, and those little varnish flakes will get in there and cause valves to stick. And so the standard procedure we would always do before we did a transmission service, whenever I was working at the Ford place, was we would always test drive the vehicle before we ever took the transmission oil pan off. And if we test drove it and we felt a problem, we'd come back and tell the customer a transmission service is not going to fix this. Now, I will say that I have done full transmission fluid exchanges and fixed some transmissions, but customers, particularly if it's a large dealership that they feel like has a lot of money, they'll try to get a free transmission overhaul or something like that. Not like I think there's not very many customers that'll do that, but there are some devious ones out there that will. And so it's the wise thing to always test drive the vehicle before you service the automatic transmission. This is true with other things too, but particularly on this question here. Now let's this video, I'm going to show you a video right quick, if I can get it to play. Maybe it's not going to play. That's not a big deal. Got some high pressure right here. I wonder why that video won't play. It's crazy. Let me see. Okay, we got this GMC Sierra idling, and we got our scan tool hooked up.
and we can actually control the pressure control solenoid with our scan tool here, because it's got two-way communications with the PCM. And what we're going to do is we're going to increase the pressure control state. And which way is our actual pressure going to go? The gauge is connected to the line pressure test port on the transmission. So, Nicholas, which way is the pressure going to go when you increase the percentage of pressure control?
Towards this way.
Okay, we're going to go lower, you mean?
Yes.
Okay, now go ahead and hit your start button. Alright, now then, let's increase make the pressure control more active. The numbers in the top right of the screen are going to show you. Look what the pressure is doing as we increase that. We increase it again. And we increase it again. Let's go up to 100% and see where it goes. If it is 100% active, my goodness, the pressure goes way down, doesn't it? Wow, look at there, and it's not even bouncing anymore. And I go the other way. Go the other way, down to 90. See how the pressure goes back up? Now, if you disconnected the power going to that solenoid, like the wire got cut, the pressure would go to 100%. But it would be like it was 0% active, and the pressure would be really high to protect the transmission. And so that's what that's all about. 99 GMC Sierra 4L60E transmission.
So if you lose power to the pressure control solenoid, it's going to default to high. That's the point. The more power that's delivered to the pressure control solenoid, the lower the pressure will go. That's just rule of thumb. Well, this brings us to the end. Let's just go ahead and see if we can score the test. Let me know how you guys, if you got anything out of this or if you learned anything. I always have fun putting this stuff together and creating these images. I'll see you guys next week.